Hello everyone, so today I want to talk to you about probability. Now, when we learnt probability in school, we weren't really given a very formal definition. We were just told that it's how likely something is to happen, right? So the probability that I toss a head is a lot more likely than I win the lottery. The probability that it rains in Britain is very likely on any day, really. So that's what probability is, that's what we were told. We were told a few simple things about probability, such as probability can only be between 0 and 1. But today, I really want to lay down a more mathematical definition of probability. So, suppose you have your sample space, so your set of all possible outcomes, and we denote P, written like the letter P with a little line to the left, as a map. So a map is just a function from A to the real numbers. So A is a subset of the sample space. So A is an event. So we denote P, a function from an event to the real numbers. And for each event A, there is a number PA, right? So each event, we assign it some real number. And the function which does that is called P. Now, we call P a probability measure if the following three conditions are satisfied. The first condition is that P of A be greater than or equal to 0 and less than or equal to 1. The second condition is that P of the sample space is 1. And the third condition is that if you have an infinite collection of disjoint events, I've got some old notes, I'll get rid of them. So if you have an infinite collection of disjoint events, so remember a disjoint event is just their intersection is the empty set, these events cannot happen at the same time, then the probability of the union of these events, so a bit of notation, but this thing here is just A1 union A2 and so on and so forth, yeah? So the probability of the union of these events is the probability of A1 add the probability of A2 add so on and so forth. Now you'll notice how I switched from using the letter P to saying probability. But yeah, so this letter P, we call it probability. We call it a probability measure. Now, that's it really, and that's what a probability is. It's a function from an event to the set of real numbers. It assigns each event a real number. And it's quite intuitive if you think about how you learnt things at school. So if you look at property number 2, the probability of the whole sample space. So say I roll a dice, I get a 1, 2, 3, 4, 5 or a 6. Every time I roll the dice, I will get something in my sample space. So the sample space is certain to occur, right? And the probability of that in turn is 1. Now, we're going to look at how these axioms came about, because I think it makes it easier to understand them. So what we're going to do is we are going to let this be 1, 2, 3, 4, 5 or 6, so our infamous rolling the dice example. And we're going to let A be the event we get a 6 when we roll the dice, okay? Now, we're going to wake up one morning and we're going to roll this dice infinitely many times, yeah? So, and we're going to let AN be the number of times the number of times event A occurs in n trials, yeah? So if we roll the dice 10 times and we get a 6 7 times, then AN is 7, okay? Now I want us to consider AN over n, yeah? Now, if we roll the dice infinitely many often, so for n tending to infinity, this thing here might converge. And we're going to assume it converges to something called prob of A, yeah? Now, there are 3 things certain about prob of A. The first thing is that prob of A is greater than or equal to 0 and less than or equal to 1, right? Because AN, the number of times event A occurs, is going to be less than or equal to n, right? Because you're repeating the experiment 10 times, so the number 6 can only be rolled max 10 times, not anything greater than that. The second thing we can be certain of is that prob of the sample space is 1. So the sample space is 1, 2, 3, 4, 5 or 6. So each time you roll the dice, you will be certain to get something in your sample space, right? So the number of times the sample space occurs is n, and that is then an over n becomes 1, which tends to 1 as n goes to infinity. And the third thing you can be certain of is that the prop of the empty set is 0. So the empty set can never occur. So say A is the event we roll a number greater than or equal to 7, well, an would be 0, and 0 divided by n is 0. Now, consider two events, A and B. So A is the event we roll an odd number, and B is the event we roll an even number. Yeah? Now, consider C, which is A union B, and similarly let an, bn, and cn be the number of times event A, B, and C occur respectively. And again, note that cn is an plus bn, and this is because A and B are disjoint. You can't roll an odd number and an even number at the same time. So for example, say we rolled the dice 10 times, and 7 out of those 10 times we got an odd number. That means the other 3 times we must have got an even number, yeah? Which means, so this here implies that an over n plus bn over n equals cn over n. And as n tends to infinity, this implies that prop A add prop B is prop C, or prop A union B. And you can see that these 3 properties come from these 2 axioms, and the third axiom, C, is linked to this property here. So that was just a way for us to basically, I wanted to show you how those axioms came about, a little idea behind them. Obviously, you don't know if this limit exists, but what we assume in modern times, what we assume in probability, and what we'll be assuming for this course is that each event will be assigned some probability. So thank you for watching, and any questions, just ask them and I will try to answer them as soon as possible, and have a lovely day. Bye.